Lesson 18, Combining Like Terms. Two or more terms that have the same variable or variables raised to the same power are called like terms. Okay, it is very important for you to understand that it's not just the same variable and the same exponents. It has to have the exact same variables with the exact same exponents. X squared and x to the third are not the same thing. Those would not be like terms. So here I have the same exponents. I have an exponent of 4, 4, and 4, but I don't have the same variables for all of these. Y is not the same as x, so this would not be a like term. So if I combine these, I would say 3x to the fourth plus 5x to the fourth. And when you do this, I always box them in, circle them in, make triangles around them, squigglies, circles, whatever you want to do. And always make sure that we're taking the sign that precedes the term. That's the sign that's right here in front of it. So on this, whenever we are adding like terms, we can always remember that we are just adding the coefficients. Okay, so I have 3x to the fourth plus 5x to the fourth. That would give me 8x to the fourth. My x to the fourth in this case is kind of like a label. It's not going to change. It's going to stay the same. And then I bring down whatever I have left. Okay. On this example, it just wants us to simplify each expression by combining like terms. So I have 4y plus 9y. Well, I have the same variable, and this y is understood raised to the first power, as is this one. So I have the same variable with the same exponent, which means that they are like terms. So I'm going to take 4y plus 9y. So all I have to do is add those coefficients. 4 plus 9 is 13, and then I just bring down my y. On B, same situation. I have n, and n. They're all understood raised to the first power, so that means each of these are like terms. We can always remember that a double negative gives us that positive. So I'm just going to work myself from left to right. So I have negative 3n plus 10n. Negative 3 plus 10 is going to give me a positive 7n. Plus my 8n. Notice I'm bringing everything straight down. I haven't used this yet. 7n plus 8n is going to give me 15n. Final answer. On C, like terms. On this one I have x, y, I have a, and I have y, x. Well, a is obviously not like terms because it doesn't have the same variables. Now this, on the other hand, the x, y, and the y, x, that could confuse you because they're not in the same order. But we have to remember the commutative property of multiplication, which states that we can write or we can multiply in any order and it doesn't change the value. So xy is the same as yx. They're both being raised to the first powers, so those would be like terms. So I would take 12xy plus 2yx. So then I have 12 plus 2, which is going to give me 14xy. And I have to bring down that thing that I didn't use, which is going to give me that negative 4. Okay, final answer. Same thing's happening here. I have x to the third plus c to the second plus x to the third plus c to the second. Things that we need to remember. Just like that understood exponent, we always have an understood coefficient. If we don't see it, it is an understood 1. You don't have to show it. I'm just showing it to ease the minds of some of you. So if I have 1x to the third, do I have any like terms with this? Absolutely. I have plus another 1x to the third. And then I have this 1z squared plus 1z squared. Okay. So 1x to the third plus 1x to the third is going to give me 2x to the third plus, then I have 1z squared plus 1z squared is going to give me 2z squared. Okay, final answer. I want you to pause the video at this point and I want you to try to do B and C on your own paper. On B, we're going to combine like terms. So I have 5n to the third, 2n to the third, nx squared, and nx squared. So I have two pairs of like terms. I have 5n to the third plus 2 into the third. And then I have plus 4nx squared plus nx squared, which I hope you remember this coefficient is an understood 1. Show it if you need to. If you don't, that's fine too. So I have 5 into the third plus 2 into the third is going to give me 7n to the third plus, because these are all positives, I have 4nx squared plus 1nx squared is going to give me 5nx squared. Alright, on C, like terms, I have xy, x squared z, xy, and x squared z. So again, I have two pairs of like terms. I have 2xy plus that 3xy, and then I have positive 4x squared z minus 5x squared z. So again, we're just working with the coefficients. Those variable parts don't change. I have 2xy plus 3xy, and that's going to give me 5xy. Then I have 4x squared z minus 5x squared z. 4 minus 5 is going to give me a negative 1, which I don't have to show that coefficient. I will right now just to ease your minds. And then I have that x squared z. Final answer. Last one here, example 3, says Olympic competition offers 3 equestrian disciplines: dressage, show jumping, and endurance. The diagram represents the measurements for a regulation dressage arena. Find the perimeter of the arena as a simplified variable expression, then evaluate the expression for x equals 19.5 inches. Okay, so what we're going to do is first we have to find the perimeter of the arena as a simplified variable expression. So for the perimeter, we know that we add up all the sides. Well, they've given us 2 sides, and that they've also told us that it's a rectangle. So we can take this x minus 1 and put it over here because opposite sides should be equal, and this 3x plus 3 is going to go on the other side. So I have to add up all these sides to find the perimeter. Let me extend my page here. So I have the perimeter has to equal x minus 1 plus, the next side was 3x plus 3, I think. Yes. 3x plus 3 plus, the next side was x minus 1. And the last side is that 3x plus 3. So, like terms here, I have to simplify. I have x plus 3x plus x plus 3x. Notice I'm always taking the sign that's in front of the term that I'm working with. I also have negative 1 plus 3, negative 1 plus 3. So x plus 3x plus x plus 3x. Okay, x plus 3x is 4x, plus x is 5x, plus 3x is 8x. And then I have negative 1 plus 3 gives us a positive 2. I'll show this here. Those 2 gives us a positive 2. Minus 1 gives us 1. Plus 3 gives us 4. So our perimeter expression, okay, you don't have to have the p equals because we did ask for an expression. This 8x plus 4 is the expression they're looking for. Then they want us to evaluate for x equals 19.5. All we have to do is substitute. So I have 8 instead of x. I'm going to put that 19.5 plus 4. So I can take 8 times 19.5 because I have to follow order of operations. That gives me 156 plus 4. And we know that will give us 160. And we're talking about inches. So, final answer, make sure you're taking good notes. I'll see you in class tomorrow.